Now that we know what machine learning and artificial intelligence are, let's see what they can do. In particular, I want to prove you that machine learning is a powerful but fragile tool to use. Let's see what machine learning models are capable to do. For example, they can be able to detect coronavirus from chest X-ray pictures. They can detect social distancing. They detect the people and then they compute the distance between each person. The machine learning models are capable to recognize objects like people, as we've seen before, and classify them. Here we can see on the bottom left that the machine learning model detected the car with the bounding box and also labeled it as a car with a 99% of confidence. In other cases, we can train a machine learning to generate human meaningful text. In this example, you see a person writing a phrase and then the algorithm generates other phrases in response. So by meaningful, I mean that they have a correct grammar and can have some sense with respect to the context. Also, the machine learning models are capable to generate faces from people that do not exist. In this picture, you can see the three faces on the left side that are combined together in some sort to generate a face that does not come from an existing person. And another use of machine learning could be to forecast future events. Here you see the future windows, which is our set of inputs for the machine learning model, and then you get the labels, the orange line here. The models want to predict values as close as possible to the orange line. For example, machine learning can be used, not very successfully actually, in stock predictions, stock price prediction. So machine learning seems, as we've seen so far, very good, very powerful tool. But what is not able to do? Well, never trust a machine learning based physician, because the machine learning model is only capable to learn from correlations and patterns between the data, nothing more. It does not get the meaning of that disease, so is not able to predict correctly. Then never use sarcasm talking with a machine learning based chatbot, because he will take it all seriously. Sarcasm is a very high level of consciousness subject. So a machine learning model is not able to detect it so far. Until today, we can say. So then never expect that a machine learning based image generator will be able to produce original content. That's because the algorithm, the image generator, is not able to generate new features. It gets a picture, a style, and it computes together to get the same picture with the style that is sent as an input. So machine learning is a mode of knowledge acquisition without explicit programming, but has some definite boundaries, as we've seen in the three examples before. Because, for example, chatbots don't learn language at all. They just infer the grammar, but they not understand the underlying context, the meaning under those words. The generators of images, audio, text, whatever, are not original and creative artists. Art is about distillation of individual and social experiences, while these generators are only capable to rearrange the previous art, what has already been seen. So, if you are in doubt if this problem could be solved by a machine learning algorithm, take the words of Andrew Ng that said, if solving a problem takes you, human, more than a second, then don't expect that a machine learning model would solve it at all. So this second is an empirical metric to understand the complexity of the task. Machine learning is able to solve relatively easily tasks. But we've seen that machine learning has some boundaries. And things can go wrong even inside those boundaries, when the machine learning models do not work as expected. For example, because models are subject to covariate shift. In this picture, we see that we have trained a machine learning model using generally people with a young age. The model is then optimized with this type of people. But if we take this model that does well on the data, on the training dataset, but we put it on production, and unfortunately, on production, most of the people are older than the training ones, then the model will behave not as expected, and the performance would, generally speaking, worse. Another problem that could be encountered developing a machine learning model are the biases. And this paper that I reported here is an astonishing example of how we can quantify the biases. In fact, machine learning amplifies the biases that is in the data that is used to train the model. And in this paper, it's presented that the machine learning model trained on newspaper reviews and so on finds that a man is correlated to the career of a computer programmer, while the woman is correlated to the homemaker. This means that the newspaper, the review, and so on inherits a bias, a gender bias. Another problem are the adversarial attacks. And this picture is taken from this beautiful paper of written by Goodfellow et al. So imagine we have trained a model able to recognize animals from images. And on the left side, you can see a picture of a panda, and the model correctly predicts that's a panda with about a 58% of confidence. If we sum the picture of the panda with some random noise, the model behaves unexpectedly. The sum of the two images gives the right one, which is just the panda a little bit blurred. But the model unexpectedly predicts it as a gibbon, with a very high confidence, more than 99%. This is an adversarial attack, but it does not mean that the model is modified. The model was the same, but has some sort of problems, we could say, inside it, that these problems are not exploited until we do these adversarial attacks. The adversarial attacks could be problematic, for example, in self-driving cars problems. We have a stop sign, and the model, which is trained on a stop sign to classify them, correctly predicts that the picture on the right is a stop sign. But if somehow the picture gets blurred, there's some dirt of camera on the camera, or whatever reason, and this adversarial perturbation sums with the authentic input, then we get an adversarial input that completely fools the model. A fourth example of problem that we could encounter during the machine learning model development are Trojan attacks. So consider a pre-trained machine learning model. We have a model that has good performance on traffic signs. On the left side, you see the normal behavior. But the model has been modified, or the dataset, depends on the techniques, the hacker techniques that are used. But let's say the model is modified by a malicious person. In this way, in normal conditions, the model behaves normally. But when some triggers are put on the images, then the machine learning model behaves maliciously. For example, on the right pictures, we have the attacker adds a 4x4 pixel onto the image, and the model is completely full and predicts speed limit. The Trojan attacks are different from adversarial attacks, because adversarial attacks do not depend on the external modifications of the model, inherent inside the model. And in fact, the researchers are trying to explain why there exist these adversarial attacks. Trojan attacks instead arise from a malicious behavior from an attacker. In fact, here the trigger triggers a specific prediction, malicious prediction of the model.